Okay, so to start things off today, just want to take a couple minutes and kind of go through some of the information for the lab activity that you're going to be completing this week. So this week we're covering the digestive system, and in the video lecture we'll talk about the different structures that we have within the digestive system, and we're also going to cover the digestive enzymes, those things that we have in the body that are going to help assist with the process of digestion. Because digestion by itself happens at such a slow rate that we actually would not be able to get the calories from the foods that we eat into our systems in order to keep things functioning the way that they were. So we have to have this assistance from these enzymes, which will speed up the process and make it go faster. The particular lab activity that you guys are going to be covering is going to look at the digestive enzyme of amylase, which is a digestive enzyme that comes from the mouth. It's actually in our saliva. So when you secrete saliva into your mouth, it is going to digest sugars and starches. So anything that is carbohydrate based is going to be broken down by the amylase. And so as you work through this lab activity, that's what you're going to be taking a look at, is exactly what the amylase does in the presence of sugars and in the presence of starch. So I want to talk about a couple of things. You guys should have two lab sheets that tie to this particular lab activity. So one that looks like this, and then the second one should look like this. So just kind of talking through the instructions. Immediately, you are not doing all parts of this lab activity. And the reason for that is there's heating and cooling, and in a lab setting face-to-face, I would actually take care of all of that and prep it for you. And since we don't have that luxury right now, then I'm going to take out that part B. So you are looking at doing part A only. And what you are going to need is you're going to need to take some of your test tubes and you are going to prep them. So one of your test tubes is going to have just amylase in it. So it's going to contain that digestive enzyme. And you have a vial in your kit that has a powder amylase in there. You are going to need to add water. And I marked on the vial where the fill line is. So you will simply fill that up to that fill line, turn it into a liquid. It has kind of a tint to it. It's not going to be clear once you add the water to it, so please don't expect it to be. And regular tap water is just fine. When we get into these labs, there are some places where it calls for distilled water, and we don't need distilled water, so you can just use general tap water, and that will work just as well. So you have your amylase in the first test tube. In a second test tube, you will have starch solution. And again, you have a vial that has starch powder in it. You will add water to it. Again, I marked the fill line. And once you add that water, then you will have your starch solution prepped. And then it says 5 mils of starch solution and 1 mil of amylase. So you're going to combine. So all of your test tubes are going to have 6 milliliters of liquid in them. It's just what those 6 mils are made up of. One of just straight amylase, one of starch, and one that's going to be a combination of the starch solution and the amylase. Now, the pipettes that I left in your kits as well, I know in part of this it calls for a graduated cylinder. I didn't travel those for a couple of reasons. Number one, they are glass and just reducing the amount of glass that I'm sending in those kits. And we also have other ways to measure out the 6 mils. And so the graduated cylinders were not necessary. If you look at your pipettes, the pipettes have are actually 1 mil from the tip of the pipette up to the bulb. You do not have to have any liquid in the actual bulb, so the part that you squeeze, that part does not have to contain any liquid, but the tube from the tip up to that bulb, that is 1 mil. And so you can do that 6 times, and that will get you to the 6 mils that you need to have in each one of your test tubes. So then it explains what you guys should do with the test tubes in part 4, and it says to have them in a warm water bath, which is 37 degrees Celsius or 98 degrees Fahrenheit for a total of 10 minutes. Please do not cut the 10 minutes short to try and make the lab activity go faster. You can set the test tubes in the hot water bath for the 10 minutes and walk away and go do something else. You don't have to sit and watch them, but don't cut that short, because what you're trying to do is you're trying to get an interaction to happen within these test tubes, and it takes time. It's not instantaneous. So if you shortchange the time, you are not going to end up with the results that you should. If anything, it's better to go longer than it is to cut it short. Now, the other thing is with the 98.6 degrees, even when we are face to face, trying to get them at 98.6 degrees is very difficult. And so what I'm going to ask you to do is to take 100 mils of water, and I gave you a beaker, so measure out 100 mils in that beaker. Warm that for 2 minutes in a microwave. So just put it in the microwave for 2 minutes. Whatever temperature it comes out at, that is what we're going to run this lab activity at, so that you're not having to measure and trying to maintain them at 98.6 degrees, because that becomes very difficult when you don't have a constant heat source to keep applying to them. So 100 mils in the beaker, heat it for 2 minutes in your microwave, take that out, place your test tubes in that. That is going to be our hot water bath. We are not going to measure temperatures. Okay. So we'll sit in there for 10 minutes, and then you are going to complete the rest of the lab activity. It talks about doing a porcelain test plate. You don't need to do that. Okay. So you're not going to find a porcelain test plate in there, and that is just fine. At this point in the lab activity, you are going to be adding the testing solutions to it. And so it talks about the iodine, which you all have a small vial of iodine, and then the Benedicts, which you all have a small bottle of the Benedicts. Iodine has to remain in brown bottles. It's light sensitive, so that is why I traveled those in the containers as they are. And what you're doing with these two is they're indicators. Iodine is going to be an indicator for any starch, and Benedict's is going to be an indicator for any sugar. So when you add these liquids to your test tubes, to the liquids you had in the test tubes, what you're ultimately doing is you are testing to see if there's any starch present or if there is any sugar present. Now, the positive color changes, your iodine starts out kind of as a brownish color, and it does permanently stain. So please make sure that you guys are not wearing clothing or don't get it on clothing, because it will not wash out. But it will convert from its brown color to either a black or a purplish color if it's a positive test for a starch. So if you put it on and it remains brown, it's a negative test. It is not sensing any sort of starch. If it changes to a black or a purple, then you have a positive test for a starch. On the Benedict's, it starts out as a blue liquid, and if it changes in the range of your yellows, oranges, and reds, so if it shifts that way in the color scheme, then it is testing positive for sugars. So you guys can kind of indicate then, and the strength of the color change. So if it stays yellow, it's a small positive, and then the strength of the test, if it goes to orange, it's a stronger positive, and if it goes to red, that is the strongest positive that you would have for the presence of sugars. So I didn't read through each one of those directions word for word. You guys are able to do that, but just make sure that you set up those initial test tubes, you let them sit for the 10 minutes, that you don't shortchange on that time, and then understanding that the indicators are going to give you a color change if it is detecting a starch or if it is detecting a sugar in those test tubes. And again, the color changes kind of tell you the changes as well.